Okay. I don't know why I didn't hit the button or find it, but what I didn't find last time was this. Remember, we loaded this hosted point feature layer that is an oriented imagery dataset, and then the client actually should recognize in itself that I can use this as oriented imagery, and then I get the user interface, and then I can actually query the layer and get, similar to what we saw before, have that in the standard client. So on the website of it, it looks like a feature class, but the client recognizes that it is an oriented imagery dataset. Because I started this thing now, and because it's not a big topic today, I want to show you a second one just to highlight that more and more the standard clients will learn basically from the capabilities of the published datasets what they offer you in terms of functionality. A second example, this is the first one, a second example would be this one. This is on my local machine, the server endpoint, the image server endpoint. And remember this example that I showed you about this Swiss combined data of the different layers of topographic maps down to whatever. I just serve this as an image service, and if I now turn on the ArcGIS Online Image Map Viewer to load this service, now it's loaded. You will see here that it has turned on a number of things that expose this to be an image service that has capabilities with it. So let's go closer because it doesn't display at that scale range. It knows this is an image collection, this is an image service, so I can open up this collection explorer. Now I see all the elements that are in this collection, and if I actually want, I could make a single item an element in my map. So if I say I definitely need this ICAO map thing as a layer in my map, I could actually add it like this. So the message here is the clients start being much smarter on figuring out what content you offer them and what they can do with it, which only enforces what I said before. Data management and whatever you pack into it is really important, because that sort of sets the capabilities that you have, that you can offer your clients in the end. And with that, let's go back to our agenda. So we want to talk about workflow automation a little bit, and then look into developer capabilities before the next break. Boom, boom, boom. Correct me or have a different thing in mind yourself, but most of the time clicking through the user interface is not really what you want to do when you have repetitive workflows or mass data workflows or something like that. You're actually looking for ways to automate that, and the ways to do this in ArcGIS, there are many, and they will largely depend on how much you want to move from UI use to programming, things like that. But they all start basically with the tools, the standard tools that are provided. And those tools are made available in always at least three ways. The user interface way of doing things. Yeah, come on, give it to me. Every single command is also a Python command. And virtually every command is also available just as a element that you can add to a model builder workflow. Depending on how much you worked with these things already, you will know model builder is super easy, but also sort of limited in if, when, and reacting on single items in a larger data collection and stuff like that. It will become rather complicated to do that. In code, you have much more freedom to do that. You know that you can now create a model builder model and then say right-click export to code. this is very dumb code, right? It's very much spaghetti code, but it's always a good starting point, specifically to see the calls of the simple single function. So create Mosaic dataset, what's the syntax of that function? If you then parameterize a little better to say, okay, the input folder is important and the dataset is important, that's what you can nicely correct out when you put that into code. A special version of code that I would recommend you to look into if you have repetitive workflows that you might want to share in the organization with other users could be the Python toolbox. So this is a toolbox basically in code. The nice thing is you can encrypt it, so you can avoid that people mess around in that toolbox. You are the one who's responsible for it. You keep the code working, and they can report issues, but not 10 people in the company can fix them and make them nicer because it's unmaintainable afterward. So Python toolboxes are a really nice way of doing things. Custom code, toolboxes, whatever. Down the lines of this, there also would be the Python notebook, which is just another version of code, just in another environment. I want to add, on the imagery side, a very important addition to that. Come on. Which is called MDCS. Have you ever heard of it? Guess where you find it? On GitHub. It's a repository on GitHub that we maintain since many, many years. And I'll show you in the next slide what it is meant to be, and then I'll give you an idea of what it is. So you have tons of commands like we saw before that are all available in the geoprocessing environment that do certain things. And now these are typical workflows with Mosaic datasets. It could also be raster export workflows or publishing workflows or whatever. So you have lots of commands, and you could build your own logic on them. Doing that in code, and specifically doing that for only slightly different workflows, repetitive, might make you maintain tons of code, which you actually don't want. So colleagues of mine who are working in the Sharjah office, which is called the Imagery Workflows office, they have created this. This is a Python framework that wraps around those geoprocessing functions. It really calls them. It doesn't do anything else but calling those functions. But it has been created in a way that makes it very, very flexible to set up workflows really quickly and modify them in an easy way once you've got into that. As everything you need to learn how it actually works. This is done through very central XML configuration files. In the end, those configuration files will be called by Python and then trigger a series of commands, including variables, including other models, including datasets, tables, you can imagine it. And in these XML, it's somehow defined how different incoming datasets will be processed to create whatever out of it. Very often, this is sort of a process that updates Mosaic datasets and then updates services based on them, for example. It's a very common thing to try to automate that one. But it could also be export, it could be photogrammetric correction and automated processing. As far as this is possible, there's many options in doing that. You find it here, and it comes along quite unspectacular. It doesn't have a user interface or anything like that. It is basically an instruction how to handle things, and I'm going to give you a very, very brief idea of what it is. So, when you download it, you will, and unpack it, you will get a folder like this, MDCS Pi master. Now, the first important information when you open that folder is it comes with a fixed structure of subfolders, which is actually a feature in itself, because this is meant to be a self-containing unit that for every project you basically copy that and store it and put it away and reuse it. And then you have in here, you have subfolders that contain certain elements that you don't have to care about the path and anything. Then you just take that whole packet, put it somewhere else. It will reference the internal structures of that. So if you go, for example, in this very important subfolder, you will see custom raster function templates, custom raster types, maybe credentials to use for server publishing, color maps, statistics. They will all be in these subfolders. The most important one here is the config folder, which will hold the different XML configuration files that you potentially use to do something in this environment. Now, I have let's just not do this. That's good. Let's stay in this thing here. I have a little example that hopefully makes it clear. That's the course materials here. So again, we do like quite often workshops on this, which are about an hour online if you want to actually do it, and then we use these examples to run things. I'm showing you in here two versions of different options of how to use that. The most simple version would actually be something like this. As you can see, I'm giving it a name, Amberg, all in the XML file, and if I edit this batch file, forget about all the questions. Oops. Come on. So this is just setting the directory. This is where is Python. But then in the end, you see I'm referencing one configuration file, and then I'm saying, hey, MDCS, run this one configuration file. And every information that is used by this thing is in the configuration file. Now, I told you the configurations are in here. So here is the configuration file, and I do the same thing, I edit it. And now this looks, and that's quite normal, this looks pretty cryptic to you, but it's actually very, very clear. This is the list of commands it's going to do. Create mosaic, add rasters, build boundaries, set properties, calculate the cell sizes, define the overviews, and build the overviews. It's a very, if you do mosaic datasets, you might know that workflow pretty well. It has output definitions here already set, the coordinate system, the number of bands, the pixel type. Remember we talked about properties? Cool. All properties are in here. You won't forget any. It just runs with all the properties you want to set in this configuration file. If you repeat this with 10 different data sets in 10 different areas, you will be sure that all properties are always set the same way. And then looking at these commands will all reflect down here somewhere in a section. So here is the command to add rasters. Again, you might have never recognized in ArcGIS Pro, because it's the same thing in the user interface. You can add many, many data sets at the same, or folders even at the same time. Every folder is a sub entry with add raster within add rasters. But here you could specify a lot more detail per actually folder and source that you use, which makes it much more flexible than the user interface. So this is the section that defines the add rasters. This is the section in this case that defines the properties of the outcoming mosaic dataset if the dataset doesn't yet exist. This adds the fields in this fun example that is basically just adding one town name, and then calculates values, right? This is the most stupid way of calculating a value. It's not depending on other fields. It's very, very simple. So you see all the commands are in this configuration file. What does this remind you of? if you open the calculate field command, you actually fill the same values. What is the expression that I use? What is the definition query that I use? It's basically the same thing. Now, this is the super hard-coded version, right? Everything is in this configuration file. Again, the more flexible you want to be, the more you might change that. So if I go to a little different version in here that has a slightly different command list, all of a sudden you find things like this. $name, $SRS. These are variables passed into the process. So you can make this react to what you have or to requirements in different calls to make it more flexible. You add from defaults to custom variables that you hand over to the process when you run the whole thing. Now when you run that, let's stick with the simple example first. When I run that, another advantage of this sort of becomes apparent if you interpret this correctly. It says log message. Every single thing you run in this environment will fill log files, which is sometimes really, really helpful if you automate things and you do not have to care about writing log messages and everything into your code. This logs everything. And when the thing has run, it does not only help you by being able to follow up on the logs. There should be some old logs in here, so let's open an older log. It also helps you to evaluate some performance things. It logs duration of processes. So this add raster process took 10 seconds. This build boundary process took 2 seconds. And they all ended with status OK. So they all tell you that things worked nicely. If you want to code all those things, timer start, timer end, record, give message, it's a lot of work. And the idea here is to take that away from you so you can focus on designing and defining the workflows. Everything we've talked about and you can imagine needing to do, using custom raster types and custom templates upon import, using regex expression to filter out elements by their name and adding them in different cycles. All this can be done inside this environment. You don't like batch files? Call them in Python. It's not any different. Here we parse a little thing, so let's open that in a simple Python editor. This is the same process of calling this in Python. Now here we have some standard flags, the configuration file, the data folder, the Mosaic dataset to create, and the data folder here, the source data. And these are parsed by adding them as an argument to the call with this is the Python way of doing it, Pythonic way of doing it. So where you call it, we don't really care. In the end, it will run as Python code in the environment of choice. The one we did has finished the batch, so it just disappeared. The run, we should see that in here on the date. Where are we? This should be us, yeah. So it added this, and I would expect that this also finished without any issues. So it created a Mosaic dataset, added data, did all the calculations, all that stuff. To be honest, I think it's somewhere in here. If not, then must be in here. Yeah, that's the one. So that's a small example. It's not really magic, but as you see, it did build all the overviews and add the images and the standard procedure that you know from this creation. Our professional services and workflows team uses this all the time. This is the basis of the Global Sentinel service. This is the basis of consulting work with many customers. Really, the idea is if you do a lot in managing imagery services and imagery compilations, think about this. There is much more behind it. You can also add custom functions to it that will come up in that list, similar to what you just saw with the standard functions. Write them in code and then add them to the system. Exporting data, publishing, all these parts are functionally available. In the documentation, which is part of it, it's very well described, and then there are sample data sets and sample publishing processes, and if you still have questions, the same offer again. Go to ArcGIS, we can connect online if needed and get you up to speed with it if you want to put your workflows into that framework. Questions on that? Yeah.
To a related question, but run different analysis and generate a lot of logs. I was wondering if ArcGIS has this built-in solution on how to analyze logs at scale. So I know there's like dashboard, which is like I think similar to Grafana or something. I wonder if it's something like Elasticsearch or something, ArcGIS way of doing things on how to analyze logs generated by ArcGIS tools.
Yeah,
like we have custom built. It's always an option, but it's better.
We have only one professional log analyzing solution, and that is ArcGIS Monitor, which is meant to monitor enterprise solutions by analyzing the logs and giving you a simplified interface to work with all the logs and the levels of logging that it does. That's specifically to help you manage enterprise scenarios, but we don't have an overall logging solution. To be honest, they are slightly different, right? This is a tool set that is, as you saw on GitHub, it's not an entire integrated piece of software inside ArcGIS. Probably the guys who wrote this never looked at some other Esri standards of logging. They do their own logging. So no, there is no generic log analysis system inside Esri. Who of you has sort of written his own workflows in toolboxes or in Model Builder or in Python? Who has done that? 1, 2, 3, 4, 5. Yeah. Yeah. So those who haven't, you might not have the need, but again, it really comes up quite often that specifically when organizations have changes in team members or when someone gets ill and someone else takes over for a while, then very strange things can happen. I can tell you of examples where just the person who took over forgot the transformation topic. And then all of a sudden there was a mismatch that wasn't apparently visible at some moment. It can be very beneficial for an organization to do these things and have them as documented workflows that potentially someone taking over can do without having to relearn the whole thing. Yes, it also needs to be documented somehow then, but on an enterprise level, this is really an important consideration to do workflow automation and documentation in a proper way. Okay, that sort of brings us to the next level. Again, here I have some basic information on you on the paths and all that, the things that you need to know as links. They will be in here. And now we go to the developer aspect of it. Come on. Okay. I don't even try to prevent you from seeing that. I put this together from 2 presentations at the Developer Summit, the European Developer Summit in Berlin, which is, by the way, a very nice event. It's a good mix between really programmer-focused topics and more generic, what has changed, what is coming, how could you work together. It's a pretty nice event. When we talk about the ability to access all the stuff we have through code, actually every single API has these capabilities that you could use. More important, something I did not stretch that much, I mentioned it but I didn't stretch it that much, is depending on what level you want to expose that functionality, it affects a different programming environment. Simple thing. If you want to do data processing and you do that on Python, that's one way of doing it. If you want to expose the same functionality on a web client so it actually is executed on the client, you would do that with JavaScript. If you do a stretch, like Julia and I discussed, if you do a stretch, you can do the stretch on the server before you send the data over. That would be probably even in the REST API. You can do the stretch when you do processing on the Python level, or you can send the image to the client, give the user a slider to do stretch, and then the stretch is happening on the client side. So where you actually apply functionality has a lot to do with which interface do you use in the end. The one that, besides me not being a JavaScript programmer, that has most options, and we talk about basically most, is the different levels of Python integration that we have and that you could use on different levels to do certain things. And there is 2 Python environments that are separate, with a huge overlap, but separate, that you have to know about. First, it's the ArcGIS API for Python. It is meant, as this already says, to connect to enterprise and online, to work on services and cloud sources and all that stuff, and do a lot of things that have to do with processing in an enterprise/server environment. And then you have ArcGIS Pro, which comes with ArcPy. Nowadays also every server comes with ArcPy. It has the same ArcPy installation on the server, so you can write tools that can be executed on the server or in Pro using ArcPy. ArcPy usually processes data locally, so you connect to the data, you get the data, you process the data. Here you might trigger processing on the server and all those extended things that a single user environment usually doesn't have. Both are fully integrated sort of Python APIs. The ArcPy raster object plays a similar important role in the ArcGIS API for Python as it does in ArcPy, but we're using it here now from the ArcPy raster environment. As you can see, the things you can do with a raster on a programming level doesn't differ anything from the more abstracted tool level that you have. So if you want to do typical GIS jobs like raster overlay, proximity analysis, distance analysis, hydrological tool set, use the ortho mapping tools code-wise, classification, object detection, you name it, all the things that are in there, they can be done through code down to the level of a single raster object. Now, what is so cool about a raster object? Is a raster object necessarily a single raster? No. A Mosaic dataset is also a raster object. A raster collection is a raster object. So they can all be treated, abstracted to the same concept of allowing you to apply functionality on them. And as you can see, these are really, really many. All modalities of imagery. coming from either the raw data or as output of other functions, and then you just interpret them as a raster object and continue working with them. So that could be from, as it says here, an expression, or from interpolating with a function incoming point data, whatever you want. And the same thing is, whatever you want to do with it, it can go to the point where you actually save the data really into a physical file, or you treat it as an object, retrieve the information, and then just forget about it. A very important concept that we have in many places, you might see it or you might not see it, is the connection to NumPy. For those of you who are aware of it, that's basically the array handling thing of Python, numeric Python. And a raster is a collection of pixels, so usually it can be interpreted as an array. And that is really, really important, because sometimes when you trigger something in ArcPy, we've had an example again in the discussion, you know the copy raster command? The copy raster command in the documentation has a little icon which says this tool can parallelize. You can say I have 10 processes to parallelize this job. Why can it do that? Because in the end, this tool splits up the process into NumPy arrays that it gives to a multi-threaded system and runs the analysis on single pieces. That is not very simple sometimes, because you have to take into account buffering effects if functions work across several pixels, especially with elevation data and things like that. But in the end, this is massively, massively powerful, because it actually can run on huge data collections and still work, because it splits up the problem. The raster object is also a very cool thing to access raster properties. Anything that is a property of a raster, once you've identified the raster object, you can get from it. You can usually get it pretty fast to analyze it and then do things with it. The standard things, yes, I get the name, I get the catalog path, or even multiple catalog paths. Then you have crazy things like raster attribute tables. You probably know that if you have classified data in the back end, you have a mapping between the pixel value and the attribute value. Get those tables, read those tables. Basic information on what it is, where it is, the statistics. All these things are really good to get from a raster object. And then you can apply methods to the raster object. A little set down here. Again, to be more specific on handling single objects as compared to doing generic reactions, though the data sets might be very difficult. This applies to all of these. Anything. Once you've got it as the raster object, you don't really have to care. You just have to still know what you're doing. That's always the same thing. You need to know what you're doing, but you can apply to any of those and interpret them as the raster object. Again, this has a lot to do with capabilities of GDAL and general raster things. Now, I said there's lots that you can address with the raster object, and there is actually very different things. First of all, we've talked about these two already. The single raster, the file, something like this. Then the raster type that we talked about, a sentinel seen as a raster type. Make it a raster object. Just say I want band 12, you get band 12. Then something that we only introduced 2 years back, the so-called raster collection. I'll show you an example in a Python notebook in a minute. And up to the point where you say the image service and the Mosaic dataset is also basically nothing else but a raster object that I can use and work against it. They have all some specialties, some ways to treat them, some maybe even some do's and don'ts, but in general it makes it a lot easier for you, because all these have generically the same access mechanisms. Once you've loaded them, you work with the same information on them. So let's just see this in a little notebook. If anyone is interested, these basic notebooks, I can share those. I actually shared those already. I just have to find the link again. So if you want to venture into it, having fully understood that I'm not a programmer, right? There's probably better ways to write code than I do. This is about understanding concepts, not about writing the best code that there ever was. There's definitely better people than me. This first example is a little example that shows you also that you can combine this. I mean, this is one of the biggest things that you can do nicely in Python. Combine it with any other libraries and start cross-working with those things. So this first box is just so we can later on print a few of the things that I said. I take a raster object and then I have all the basic information. So I did a little thing that reports on rasters just to show the concept. And same thing here for raster collections. So just some routines to do that. Now, just to give you a few examples of how this has to be understood. Here, this is the most simple case. This is a simple single image out of the collection I already used a few times today from the Swiss mapping thing, a single raster. These are 3 tiles of the digital surface model of that raster that I will basically combine into a list of 3 rasters. Then, similar to the list of rasters, I create a list of names. And this is basically all that makes it in the definition of a raster collection already. I basically combine raster data and raster attributes into a dynamic collection of data in code, right? Just for doing something with it. So these are basically the inputs. And now I can look into loading these things and look into the single map sheet to start with. So yes, in code, I can now start loading that raster. I can ask it to give me all the information about it. We've had this topic before today, right? Could I get this from the get raster info from Esri? No, I couldn't. That's why I loaded the GDAL libraries in addition, and I asked for this specific one element in here by, where is it? Come on, where's the GDAL? Here. I get one piece of information from GDAL info. The rest is coming from the raster properties of the raster object in itself. Just to show how you combine whatever tools you have. There's very well-known other libraries, the Pillow library, other very generic image libraries that sometimes come in very handy that you might use together with the capabilities that ArcGIS offers. And then if you want to, I mean, you can even go and start rendering inside the notebook by taking the image and defining how you want to render it and then render it the way you have it. This is now the example of a few Sentinel scenes. So here I have a different band combination of 4 bands in it, and I have a raster function, this time in code. It's an XML that says give me the near band combination, and I run it, and it returns me the image in the near infrared band combination, using here a function that says apply this raster function template in code. Right? Then here we have, sorry, this is the one, this is a single raster file, again applying raster function, another raster function that we have. We talked about stack. You can also do things here. You define a connection to a cloud store. This is the cloud storage connection. And then you query the data sets through the Stack API. It's probably not on. Oh, I should have done that first. That usually has to fail now because I did it. Yeah, first this one needs to run. And now this should work. Show effect. Okay, so these are very basic, very simple things how to use the raster object in code, apply either functions that are standard functions that you can call. In this case, I even call it from the Spatial Analyst toolkit, or functions where you have saved away a function chain, like I did it here as the function chain in XML. Just to give you an idea of some of the things that you could do. That's the standard raster object. The next level of it is the raster collection. I already had this creation of a 3 raster collection in that notebook, but I didn't do anything with it and I didn't remember it. The raster collection is a pretty interesting thing. In the center of the data model there is the single raster, and now depending on what you want to do, you have different options what you create out of those rasters. We've been talking about creating a compilation in a mosaic dataset, which is sort of more the idea that you might need that for a longer time and do something with it, serve it as an image service, use it as a raster collection, output it into a multidimensional image data cube. The arrows are showing everywhere because all these elements can be combined and used against each other in combination or in converting or interpreting them as that. The raster collection compared to this is more the idea, I do not do a durable thing like a mosaic dataset. I do basically just a collection of images for a certain analytical purpose. I do my analysis and then I potentially dump it again. So to give you a simple example, we had done crop detection analytical workflows with the Spanish colleagues on certain areas of Spain, and it basically was going to the planetary computer, selecting with the Stack API the relevant images. On those raster collections we removed the cloudy pixels, created composites of cloud-free quarters, and then did the crop detection AI on it. On some of it we also exported into multidimensional, multi-temporal data sets. But there was never a mosaic data set, there was never an image service from it. It was a pure processing workflow that started code-wise and went actually this way. So this is a really nice way of dealing with things. And the very nice thing about raster collections is the idea to be very flexible, similar to other data constructs with filters. Then an important concept here is the so-called mapping of functions. Those of you who program, they know this mapping of functions from other things. You'll see it in code in a minute. And once you're done with that, you still have all the abilities to reduce, combine, whatever, and get your output to the level that you want to. Here, typical things that you do with raster collections. Here, all the filtering thing. Then here, all the more pixel by pixel statistical things that you often do to create composites. And then the different I would say that modifiers to mosaic data together, select certain bands, sort them, whatever, and convert them to multidimensional data set in the end. So those of you who like data processing through code should definitely look into raster collections if you haven't done so. And again, I'm going to show a little example as a notebook. Same thing here. First, a little bit reporting, and then this comes back with the single files. I had that in the other code too. I don't know why. Okay, now here's the same thing again. We have those single files, and then we define them to be a list, a Pythonic list. We add attributes, but this time I add 2 attributes, one for the naming and one basically to represent time. And then we make this a raster collection. Done. As you can see, it worked instantly because it's by reference. It doesn't really do anything yet. And now this shows you the concept of the mapping functions. Here is a function defined, a very simple one that basically just gets the min and max of all involved data sets of my list of rasters that I input to it. And the call of that is basically here. The return will be 2 values. I give it a raster list. Now for every item in the raster list, this mapping function will be used. It will be running through every single of those items, summarize the values and return them as the complete min and max, and then I have a little reporting function. So if I do that, geez Louise, you see it was sort of quick. It's only a few data sets. The overall minimum, the overall maximum, the number of rasters I ran through, the different fields the raster collection has with the names and the values. And then visualizing them in their spatial context here, those 3 elevation data sets. And as I said, another important feature is I can filter now. So the simplest way would be something like this. I filter by the attribute. I use the name field, and it has to be 3. And then output the same thing, rendered now to the min and max of just this raster. So it's visually sort of appealing. So that happens like this. What would happen if you do, use a min function or a max function from the geoprocessing environment on top of one of those rasters? What would always happen? I know I'm asking a lot in terms of attentiveness and everything. Traditional geoprocessing of imagery, what does it do? It does file input, function, file output. You always create additional files. That's a very traditional thing in image processing. We get away from that everywhere. The raster functions get away from it. These things get away from it. You dynamically access data. You create whatever you need to create. It's only happening in memory. It's based on concepts, like I said, chunking up the problem into codable things, creating results, forgetting about the rest. I mean, every one of these 3 tiles isn't really big, but still, if you trigger that, create a new file from it, it takes a while. Clicking here and saying, get me the statistics of all of those 3 files was basically instantaneous. It's just a different thing. And for that, for analytical workflows, you really have to start thinking about using these things. Do you have raster collections also in ArcGIS Pro as tools? Yes, you have. You don't need to be able to code. You can do it. But the bigger your problem is, the more flexible you want to be. I'm pretty sure you're going to look at the coding side of it rather quick. I'm using another sample raster collection on this one here. So here we have, here it is. Here we have a Sentinel-2 example again, 3 Sentinel scenes, a few more variables that are detected and read out, the tag value of how this data set was processed. So you see that's already the same thing. Lots of information on those data sets. Now, another way of filtering that is on large collections pretty important is do something like filter on time. So let's do this. Then the mapping function, again, for every single one that is still fulfilling this requirement of being filtered by time, we now want to apply an NDVI function. Here, the NDVI function is basically taking the raster object, getting the 2 relevant bands, and here in a very simple way, doing the real calculation how NDVI is done. What would be an option, a different option to do it? Call the existing NDVI function. But here I wanted to just show that even if we don't have the function you're looking for, you can just write it in code. Right? That goes more to your scientific approach of it. Whatever you want to be writing in terms of the logic of NumPy or math, or just write it. And then return the data set. Now, I mapped this NDVI function. The outcoming thing is my NDVI-based raster collection. Every single item in there is now an NDVI data set. And you will see again, it's not as super fast as the other one, but that's what it was. It now took 3 Sentinel scenes, created the NDVI, put them into a new raster collection that you could now start working on. This is an example of an even bigger data set. The source this time is a CRF. This CRF is already a multidimensional data set with many, many time slices in it. Remember that on this slide, on this slide, I said you can move back and forth between those things pretty easily. That's exactly what happens here. This is a CRF, so this is a multidimensional image cube. It has attributes inside the data cube, and now I read this in as a raster collection. Once I've done that, and you will see again, reading this in is instantaneous basically, I now have all the information. This thing contains 26 processed Sentinel-1 scenes. I have the time and the raster, that's the attributes that were put into this collection. And let's just keep it simple in this case, and let's just visualize a renderer that does a summary, and actually it uses a simple raster function template called coherence sum rgb2 rft.xml. Do you recognize what this is? Sorry? Someone?
Gaza sector.
Yes, this is the Gaza sector. Actually, it's a clip of the Gaza sector limited to a deep learning classification of the inhabited areas of the Gaza sector that were built up areas before the Gaza conflict. These colors show you a Sentinel-1 analysis done by Coherence about the frequency of destruction in the inhabited areas, done by Sentinel-2, done by the bombings of the Israelis on the Gaza Strip. Don't get me wrong, I'm not for what Hamas did. This is, how do you call that in English? Genocide. Sorry. I work a lot with humanitarian organizations. You can't believe it. I should take this example out, it always touches me too much. Anyway, it shows that with very simple means and existing data that's out there and creating data collections, you can do really, really fast analysis. This really happened when I clicked this button, right? It's massively, massively powerful. Yes, don't get me wrong, this data set has been clipped to the extent of Gaza before, right? And every single of those Sentinel scenes has already been processed as a coherence layer, always covering, I think, 10 days. So there has been some pre-processing, but it still takes all those data sets, sums them up, applies a function template to it in code as basis of a raster collection. Let's get here. This thing that I told you is in itself very positive. I'm sorry, it also puts a lot of burden on you to decide again what is the best order of things to do, what is the best workflow. And really my recommendation would be start that decision by how often do I do it and how persistent do all the intermediate results have to be, or do I need them or do I not need to do them. The more you want to do like quick analysis that produces a result, but then you forget about everything that has been underneath it, the more you would be on this collection analytical side. The more you build up data sets that you use for a long time, that grow over time, that have a constant meaning, the more you're on the side of the mosaic data set, the image service, and those things. Also, I mean, the things that I showed you, if here you don't have a good data connection and you're trying, you can do that. You can do that right through a stack connection to cloud-based data and create a raster collection, but you will see then the processing performance will highly, again, depend on the quality of data connection you have. But you can do it, and then physically, outside of if you do not say save, nothing will ever be on your disk. You will just process and do results and do whatever you want. So, not necessarily an easy answer for you, but a quite powerful thing to do. That was the raster collection and ArcPy raster. The third thing, we have to talk about is now the ArcGIS API for Python. What else do I need, basically, now to do these things compared to what we've seen before? The best way to show this is with a third notebook and some few examples. So now we're going to connect to an environment, be it your enterprise, be it ArcGIS Online, something where you first basically have to authenticate. So you see I'm importing both ArcPy and ArcGIS. I'm also using IPython here for some display things. So let's get this started. That's a bad one. I always sign in automatically. Give me a second. What is that? Okay, let's get going. This I did already, right? Okay, let's sign in. Yay, worked. Same thing here, like we had before. Okay, this we loaded. This we've done before, but now we're interested more in this one. Now that I am signed in with a valid account, I can actually start connecting to services. This is the Sentinel service again, but thinking of it on an enterprise level, you would do the same thing. You would sign into your enterprise environment, and then you would be able to access services in your enterprise environment. So let's use this example, connect to the service, define, in this case, hard-coded a certain extent, also create a spatial reference object from it for two different queries. I've done that here because you need two different objects. Then I create a definition query that actually uses the Sentinel tile number only primary data, cloud cover less than 10%, and acquisition date later than October 24. This would now be 49 objects. So let's make this even smaller. No, it uses one item later. Okay, so take it as an example of how to filter from a service, an image service, the items that you're interested in. This would be 49 items in this case. Or just get the content in terms of specifying a certain layer in your system. This is the global service again. And then query this layer, what it actually can do. So it now lists you all the functions that have been published together with the service, so you can just call them. And do the same thing again. Take one of those functions, apply it to color infrared with DRA. Renamed. See that? It's now color infrared for visualization. Okay, so now you see it takes a while because now it goes back to the service. It tells it which function to apply. It delivers the image back. I now limit the extent. This was for the developer summit. We might be actually able to change that to Tallinn, but then we have to define a new extent. So now I'm going to some area in Berlin. I'm defining even which base map to use. I'm defining to add the color infrared that I had defined at some point. There it is. And apply this basically to a new map for the area of interest that I had created. This already shows you what the difference really between those two things is. The one is really handling images, and now we're talking about accessing services, combining them to maps, querying properties of the data sets that you're allowed to reach. Same thing again here with the Stack API. In this case, again, we do have the credentials to do that anyway. But let me still go on a little bit. While it still retrieves the images from the planetary computer, along the lines of the discussions we had in the break about stretching, you can hand over anything, right? This hands over, as an example, a custom stretch definition. I want to do standard deviation 3, gamma 1.7. This collection has 2 images, so now let's render it. There it is. In colors, get the size, all that stuff. Once you have access to things like that, what you can do is unlimited. Use models that we basically published. This is a deep learning model. That was another question in the break. Any function chain you create, you can publish that as an item in your organization. So you can get users to use predefined function chains if you allow them to do so. So this would be an example that I'm not going to run live because the deep learning part would take a while. But just in code, so you see what's actually happening, I use the image analyst function, classify pixel, using deep learning with the dynamically selected data from that service that I saw before. I have the arguments here, tile size 512. This model has 2 levels of labeling objects in 2 different classes, class groups. So you basically parse that along. And then you do inferencing in ArcGIS Online. What does that mean? if you do deep learning in ArcGIS Online?
You run the model, basically.
You run the model, and what does that mean in terms of hardware and stuff? We spin up those resources in the back end for you. So if this is a model that only runs on GPU, we will spin up, or we have processing machines up that will get this task, run it, deliver the result back into your either here code or as a layer into your account. Does it cost you? Yes, it costs you credits. We do that against credits, right? But still, this is an important piece of information, because you might really be able to make your own or get your own deep learning models but not have the appropriate hardware to run it. You can publish it onto ArcGIS Online and run it there and have us spin it up and run it for you if you want that. In this case, I did logically pre-process the result, and then I can, if I want to, in a notebook also take a predefined file and have defined everything on my own here, just to show you that really everything can be done in code. So this is the classification values coming out of it. This is the simple mapping with colors that I have, and then there is the attribution to it, and then you create some image. This is Berlin to show it. And add it if you want to the map widget and whatever. We've talked about this already, from raster collection to data cube. I told you that this is a very common workflow, so it's a safe process, right? And then you save it to a cloud store, to your local file, whatever. This would be the process through the ArcGIS API for Python to create an image service in your ArcGIS Online organization. You publish a hosted imagery layer based on input data. You give it context information, key things, and then it will start uploading the bundles and create the image service, which in this case failed because I'd done it before and the service already existed. I remember that one. And that was when it worked. Then you can look at that again, similar to any other layer. And if you, in the publishing process, if you already defined who will get access to it, I didn't do in this case, you just share it out with user groups and give access to user groups the way that you actually like it. The result here is really an image service. I'm pretty sure I have deleted that service already again, because it was just an example that you can then, keep up and running as much as you want. Which two kinds of image services do you know on ArcGIS Online that you can share? There's two different versions of services that you can share in ArcGIS Online. This is a publish hosted imagery layer, which is tiled. Do you know the tiled imagery layer? Or I can't ask it that way, otherwise you know that I'm doing the wrong thing. Who knows what a tile cache is? A tile cache is something we have since 20 years. It is a processing of some data into a heavily optimized, and that's very important, 8-bit 3-band representation that is tiled up heavily, and that can be served basically through a tile handler. It's a very simple technology, HTML tile handler, that drags tiles and throws them at the client. Tiles don't have attributes. There is no information left in the tiles where the data comes from. It's really meant to be a backdrop. About 5 years ago, we introduced the tiled imagery layer. We're very good at finding names that leave you absolutely clueless of where the difference is, right? The tiled imagery layer supports all bit depth, all bands, all things. It actually even supports things like the CRF multidimensional representation. It's in ArcGIS Online, it's in ArcGIS Image Dedicated. It is not yet in Enterprise, but hopefully soon. And the tiled imagery layer is exactly what I created here. It's a layer that is also very heavily tiled. It's pre-processed. There is no knowledge left if you seam-line something together. No, it's only tiles now. But those tiles can be much more than a tile cache in terms of the depth of information in it. And it's also handled through a tile handler when it's served out to the user. So it's pretty performing. This is one option you have. Tiled image services you can share with anyone. Tiled image services, if you create them, they will only cost you the amount of data that is stored in ArcGIS Online, which is really minimal. I can show you this because I like to be transparent, right? Understanding credits in ArcGIS Online. Don't ever say we didn't tell you. Here, for tiled imagery, storage cost is 1.2 credits per 1 gigabyte stored per month, calculated hourly. Which means that if for 5 hours in a month you put a terabyte up and then you delete it again, it will be averaged out, right? You don't pay this for the whole month then, but only for time because it's calculated hourly. 1.2 credits. I know from Esri that most users we have, they never ever use the credits they have in ArcGIS Online. I don't know if anyone's here that ever ran into a credit issue. You did? You did? These are the customers we like. So you need more credits, right?
Yeah. A bunch of stuff.
Yeah.
But I did so many tests with stuff
So did you get the problem solved?
Yeah, eventually, yeah. Just when we came back to some credit, then
if you need more credits, Ivo is ready for you.
We know, like, last year we had some help.
But on a global scale, really most users never use up their credits. They have more than they use. Give it a try. Some of your foundational image data that is tileable, put it into that system because you don't have to care about it anymore, right? It's safe in terms of it doesn't get lost. There is backups and everything in place. It is quite performing as tiled imagery layers. You don't have to run it through your own infrastructure. And it is comparably cheap. This is just math. If you figure out that you have, and this is about the number, if you have more than 20 terabytes of tiled imagery, then it's likely that a system of your own cloud store and your own machine that serves this out is better. But 20 terabyte is quite a bit. Not too many have that. Before that, you just have to do the math. What do I pay per credit? This is depending on your contract. Not everyone pays the same. In global, we have averages which are about 10 European cents per credit. So if you see that you pay here 1.2, that would be 12 cents global average per gigabyte per month. It's not that expensive compared to running your own infrastructure, taking care of security and all those things. So give it a try. These are the tiled imagery layers. And then there is a second piece of information in here, which looks very, very different. Dynamic imagery layers. Now, what are those? These are really the equivalent to real image services. So, unfortunately, the colleague has left who knew about overlapping and all these data sets. If you have massively overlapping data sets where you dynamically have to filter, if you do mosaicing like we talked about, then you need dynamic services where you basically pump in data and you do dynamic selection of single images without losing that context. That's dynamic services. You can spin those up in ArcGIS Online, but there you see the prices go up quite a bit. They will be depending on the number of images in the service, and in addition, the data volume is the same as the other one. So you have to be a little bit more careful here. Here, your own infrastructure, something like image dedicated or an image server, pay off much earlier because this is more expensive. But there is one, I think, much more important information on this. When we started this, we limited it. You can't publish dynamic image services outside of your own organization. You can only allow your people to access them. This is again for performance reasons, because we do not know what happens to those services if you give them to the public. And then it might just be killing our infrastructure. For now, this is still valid. If you do dynamic services, you can only share them inside of your organization. But this is this example that I did here is publishing a hosted layer, not a dynamic layer. A dynamic layer, you could publish it in pretty similar ways, but the service type that comes out of it would be quite different. How can you do this if you don't want to do code? You can do it in Pro. Yes?
Question about the credits. You sort of run learning packages which consume credits or tokens, whatnot, and are there any like try run options that I can just how much it's going to pay directly or not?
The recommendation if you run deep learning packages in ArcGIS Online is, and this is also reflected in the ArcGIS Online user interface, usually the first thing before you can actually run it at scale is you have to, it will tell you about the credit use for this process if you trigger it. And the recommendation usually is that you first do a test area, then you look into the user interface and define where you actually want to run it, and then you wait till the system gives you, this will cost you that many credits, because it does that. It calculates it, and that's exactly what it's going to cost you. And only then you say, okay, let's do it. You don't have to. And the reason why there is no generic pre-information is the function chain that you give it. It could be a function chain that has, you know, a deep learning tool in it, and then some other geo tools that require credits. It will depend on the function that you run and on the complexity of the problem. But you always get the information, how much is this going to cost me if I run it for this area in credits. So if you don't want to do these publishing things through code, there is this Create Hosted Imagery button in the Imagery section. And it's basically a wizard-based thing that you see that here does exactly the same thing. I want to publish tiled imagery. I want to publish dynamic imagery for a single image, a collection, a mosaic data set. And then you go through these steps, and it will do the data uploading and the service creation and all those things. Be a little careful. My experience with mosaic data sets, if they are sort of complex, I doubt it really works well. If they are just very simple, then it gives you the results that you're probably looking for. With that, we're at the next break, right? Oh, I have 15 minutes? Cool. I might not spend them entirely on this, but I'll give you some other examples, for example, to show you things. Combining this with the workflow part, I'll call up another notebook to do this. Okay, this is a suitable example. This I cannot share with you, but get the concept. Get rid of this. Now we combine all of this together in this last example to just show you how workflows realistically might look like. This is about the flood data that I told you about already, and as you can see, it will use ArcPy. It will also use some cloud access logic, and it will create a massive multidimensional data set with different criteria that is part of the data that is actually stored in the cloud. And in the end, it will write out a list of files, and out of that list of files, create a multidimensional CRF to be used. Quite often nowadays, we actually have to work with cloud-based data, so we make use of the different tools that are available to run through cloud data. Let me just flip down to where it gets interesting. Here, this is just creating the table stuff, but things like that become more and more important. You know, using cloud-native technologies to walk through buckets and get certain objects and find certain keys, and then list the data sets in there. The story behind this is there are thousands and thousands and thousands of those data sets for all over the world and all different scenarios, and they are partly updated continuously, and you need to be very flexible on recreating these data sets, in this case on a country level. Then there is a lot of manipulation happening here where you take the single TIFF files, and then there is a naming convention. So by the name of the TIFF file, you can actually extract what data tile it is actually in. Then you figure out it's in which hemisphere of the world is it, and then you have to apply certain corrections to that thing. The naming convention also includes the coordinates that are defining the boundary of every single one of those tiles. Can you imagine, again, I'm stressing you so you keep thinking, can you imagine where this can also be used really, really nice? To just create the polygon feature class for a mosaic dataset. If you have the bounding coordinates, and very often they are actually part of the naming convention. You can get a really, really fast system for many, many records if you have this information available, because then the system doesn't need to read it. Then you extract some data information from it, and you create a huge list with fields and properties, write out a table with a cursor, and add this into a list of files to process. Then this is where basically the handling of single images ends. Now we have a table. Now we go back to what we talked earlier. Now we add rasters to a mosaic dataset just by code, using the list we created above with all the additional informations that we've retrieved from the naming conventions and all things. Remember, I told you if it's important, start adding indexes on fields that are important. This is what happens here. You add indexes. Then we set properties of that newly created mosaic dataset, including here time settings, including the fields that are really relevant if you use this dataset. So you don't see shape in here, you don't see min PS. high and low PS. In here you only see min and max. So you define the properties, apply a template, here edit the raster function, replace it with a raster function that is pre-processed specifically for that case, and this is again only a special case, and in the end somewhere, no data, build the multidimensional info of the dataset, publish it, and then export it into a multidimensional CRF. The result of this, I can at least show you an example. This. Yeah, let's do this easier. I already have this in here. The result of this for Burkina Faso looks like this. And we're going to see this again when we talk about multidimensional data. So you see it has a classified legend, again from flood risks. And if I activate that layer, it is a multidimensional data set. It does have a number of different things. First of all, this is a very generic variable that for all values takes the default that they wanted to use. I can't explain that now, which is only for 2020. But as soon as you go to these, you know what these are, SSPs? These socio-economic scenarios that the world, if we behave good, how are they called? Socio-economic whatever. If we behave really good, then our future might potentially look better. If we behave bad, it's worse. And these are, I think, from good to bad, some typical scenarios here. So let's look at some area in more detail than we see that.
Climate scenarios.
Yeah, these are the socio-influenced climate scenarios, yeah. So this would be the all-default flooding scenario in this area on an average 5-year flood period. In a 1,000-year flood period, it would look like this. If we don't behave really well, it might be even worse. And in 2050, in this case, not so much. But sometimes it also massively changes if you change the year again. So you see there's quite a number of variables in here. The different scenarios, not all of them have, but this one has just one. This one has several years. They all have the 5-year to 1,000-year flood scenarios, and that on a countrywide level. Now I ask you, how long did it take to build that data set with the code that I showed you? For Burkina Faso. Just throw me a number. How long does it take? Cloud-based data sources.
2 minutes.
2 minutes? We have an optimist here. No, but you're absolutely in the right dimension. Building that logic data set took 7 minutes from start to end. Exporting it into this CRF that I'm using here so that I'm independent of accessing the live data, and accessing the live data would be slower. Definitely took longer. I had to do that without sitting in that cloud segment. I started in the evening, it was done in the morning. They told me at Médecins Sans Frontières that if they do that on a country level, it takes about 2 hours to run it inside their environment. But it shows that with these code-based data compilations, you can do massive things, and doing the same thing in the user interface would be very strenuous, right? Create new fields, select images, calculate field by item, all that stuff. It would take really, really long. So the end message of this programming thing is you don't have to program for every single project that you have, but you should think about it. It is very, very effective. And in the end, it still gets integrated into the Mosaic dataset, raster collection, whatever environment in the same way, but it speeds up the process of doing this just massively. And now we're at the break, right?